The arc fault circuit interrupter, or AFCI, appears to be self-indicating, as it has an indicator light or display that illuminates if the device has tripped. This is a safety feature that allows users to quickly identify and address tripped AFCIs, reducing the risk of electrical fires. The automatic and periodic self-test feature is also a benefit. AFCIs should test their circuitry to ensure they are functioning correctly. This self-testing ensures that the AFCI will trip if it detects hazardous arcing faults, even if it is not actively powered by a load. The RJ-45 connector and onboard MPU, or microprocessor unit, suggests that this AFCI is part of a more advanced electrical system like a smart home or building automation system. These features enable remote monitoring, fault reporting, and potential integration with other smart devices. Early AFCI designs had issues with false tripping and reliability, but modern AFCIs have improved in these areas. This means that AFCI technology has reached a level of maturity where they are reliable and ready for use. It is essential to note that AFCIs should be installed and maintained by qualified electricians to ensure their proper operation. Homeowners should also be aware of potential false tripping scenarios and take appropriate steps to address them. Overall, the AFCI is a well-designed and self-indicating device that uses advanced technology for enhanced safety and system integration. AFCIs are becoming common in modern electrical systems due to their ability to prevent arcing faults, and their reliability has improved in recent years. An AFCI is a circuit breaker that breaks the circuit when it detects electrical arcs, which are a common cause of electrical fires. AFCIs are designed to protect against fires caused by arc faults, which can occur when damaged or deteriorated wires create unintended electrical paths. Unlike standard circuit breakers that protect against overloads and short circuits, AFCIs detect the unique characteristics of arc faults, such as erratic and high-frequency current fluctuations. There are several types of AFCIs, each designed for specific applications. Firstly, branch or feeder AFCIs protect the entire branch circuit typically installed in the electrical panel. Secondly, outlet branch circuit AFCIs, or OB-AFCIs, protect the entire branch circuit and can be installed in the first outlet of the circuit. Thirdly, combination AFCIs provide both branch or feeder and outlet branch circuit protection. Fourthly, dual function AFCIs combine AFCI protection with ground fault circuit interrupter, or GFCI, protection suitable for areas requiring both types of protection. AFCIs work by monitoring the electrical current for patterns that indicate an arc fault. They use sophisticated electronic circuitry to differentiate between normal arcing, such as that produced by a switch turning on or off, and dangerous arcing caused by faulty wiring. When an arc fault is detected, the AFCI trips the circuit, cutting off the flow of electricity and preventing a potential fire. AFCIs are required by the National Electrical Code, or NEC, in many areas of the home, including bedrooms, living rooms, dining rooms, and other habitable rooms. The specific requirements can vary depending on the local jurisdiction and the addition of the NEC being enforced. AFCIs offer a number of benefits in terms of electrical safety. Firstly, they prevent electrical fires by detecting and interrupting arc faults before they can ignite surrounding materials. Secondly, they reduce the risk of electrical shock by quickly cutting off power in the event of an arc fault. Thirdly, they provide added protection against hidden electrical hazards that may not be detected by standard circuit breakers. Proper installation and maintenance are crucial for ensuring the effectiveness of AFCIs. It is important to have AFCIs installed by a qualified electrician who can ensure they are correctly wired and functioning properly. Homeowners should test AFCIs monthly by pressing the test button on the device. If the AFCI does not trip when the test button is pressed, it should be replaced immediately. Common issues with AFCIs include nuisance tripping, where the AFCI trips unnecessarily, and failure to trip when an arc fault occurs. Nuisance tripping can be caused by various factors, such as electrical noise from appliances or shared neutrals in the wiring. If an AFCI experiences frequent nuisance tripping, it is important to investigate the cause and address it. Failure to trip can be caused by a defective AFCI or improper wiring. If an AFCI fails to trip when tested, it should be replaced immediately. When choosing an AFCI, consider the specific requirements of the circuit and the area where it will be installed. Ensure that the AFCI is rated for the appropriate voltage and current, and that it meets all applicable safety standards. Consider the type of AFCI that is best suited for the application. For example, a combination AFCI provides the most comprehensive protection for branch circuits, while a dual-function AFCI is ideal for areas requiring both AFCI and GFCI protection. When installing an AFCI, follow the manufacturer's instructions and all applicable electrical codes. Ensure that the AFCI is properly wired and grounded, and that all connections are tight and secure. After installation, test the AFCI to ensure that it is functioning properly. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to install the AFCI. In addition to AFCIs, there are other devices that can help protect against electrical fires, including ground fault circuit interrupters, or GFCIs, and surge protective devices, or SPDs. GFCIs protect against electrical shock by detecting ground faults, which occur when electricity flows through an unintended path to ground. SPD protect against voltage surges, which can damage electronic equipment and cause fires. AFCIs, GFCIs, and SPD provide comprehensive protection against a range of electrical hazards. AFCIs are an important safety device that can help prevent electrical fires. By understanding how AFCIs work, their benefits, and how to properly install and maintain them, homeowners can help protect their homes and families from the dangers of electrical fires. In conclusion, AFCIs are sophisticated devices that play a crucial role in modern electrical safety. Their ability to detect and interrupt arc faults, combined with regular self-testing and integration with smart home systems, makes them an essential component of any comprehensive electrical safety plan. Remember to consult with a qualified electrician for proper installation and maintenance to ensure these devices function effectively and reliably. In modern electrical systems, understanding the interplay between AFCIs and other protective devices like GFCIs and surge protectors is essential for ensuring comprehensive safety. While AFCIs focus on detecting arc faults, GFCIs protect against ground faults, and surge protectors safeguard against voltage spikes. These devices work together to create a layered defense against electrical hazards. When an electrical system is designed, the selection and placement of AFCIs are crucial decisions. Factors to consider include the specific requirements of each circuit, the potential for arc faults, and the overall layout of the electrical system. It's important to note that while AFCIs are highly effective, they are not a substitute for proper wiring and regular electrical inspections. A well-maintained electrical system is the foundation of safety, and AFCIs provide an additional layer of protection. Troubleshooting nuisance tripping in AFCIs can be challenging, as it often requires identifying the source of the false arc fault detection. This may involve inspecting appliances and equipment connected to this circuit, as well as checking for loose connections or damaged wiring. In some cases, an electrician may use specialized testing equipment to pinpoint the cause of the nuisance tripping. Advancements in AFCI technology continue to improve their performance and reliability. Manufacturers are constantly developing new features and algorithms to reduce nuisance tripping and enhance arc fault detection. Staying informed about these advancements can help ensure that your electrical system is equipped with the latest and most effective safety technology. The NEC provides detailed guidelines for the installation and use of AFCIs, including specific requirements for different types of circuits and locations. Adhering to these guidelines is essential for ensuring that AFCIs provide the intended level of protection. Local electrical codes may also have additional requirements, so it's important to consult with a qualified electrician to ensure compliance. The self-testing feature of advanced AFCIs is a significant advantage, as it provides ongoing assurance that the device is functioning correctly. Regular self-testing can help identify potential problems before they lead to a dangerous situation. Some AFCIs also provide visual or audible alerts to indicate the status of the self-test. The integration of AFCIs with smart home systems offers new possibilities for remote monitoring and control. Homeowners can receive alerts on their smartphones or tablets if an AFCI trips, allowing them to quickly respond to potential electrical problems. Some smart home systems also allow for remote resetting of AFCIs, although this should only be done after the cause of the trip has been identified and addressed. When selecting an AFCI for a specific application, it's important to consider the available features and benefits. Some AFCIs offer advanced diagnostics, such as the ability to identify the type of fault that caused the trip. Others provide enhanced protection against surges and voltage fluctuations. Choosing the right AFCI can help optimize the safety and performance of your electrical system. The long-term cost of AFCIs should be considered in the context of their potential benefits. While AFCIs may have a higher upfront cost than standard circuit breakers, they can help prevent costly electrical fires and protect valuable property. Additionally, some insurance companies offer discounts for homes equipped with AFCIs. The installation of AFCIs is a relatively straightforward process, but it's important to follow the manufacturer's instructions carefully. If you are not comfortable working with electrical wiring, it's best to hire a qualified electrician to perform the installation. Proper installation is essential for ensuring that the AFCI functions correctly and provides the intended level of protection. Regular maintenance of AFCIs is important for ensuring their continued effectiveness. This includes testing the AFCI monthly and inspecting it for any signs of damage or wear. If you notice any problems, such as a loose connection or a damaged component, have the AFCI inspected and repaired by a qualified electrician. The use of AFCIs is becoming increasingly common in new construction and renovation projects. As awareness of the dangers of arc faults grows, more homeowners and builders are choosing to install AFCIs to protect their properties and occupants. The NEC is also continually expanding the requirements for AFCI protection, reflecting the growing recognition of their importance. AFCIs are not a one-size-fits-all solution, and it's important to choose the right type of AFCI for the specific application. Factors to consider include the type of circuit being protected, the potential for arc faults, and the presence of other electrical devices. Consulting with a qualified electrician can help ensure that you select the most appropriate AFCI for your needs. AFCIs are an important part of a comprehensive electrical safety plan, but they should not be relied upon as the sole means of protection. Other safety measures, such as proper wiring, regular electrical inspections, and the use of surge protectors, are also essential for ensuring a safe electrical environment. The future of AFCI technology is likely to involve even more advanced features and capabilities. Manufacturers are working on developing AFCIs that can better distinguish between nuisance tripping and real arc faults, as well as AFCIs that can provide more detailed diagnostic information. These advancements will further enhance the safety and reliability of AFCIs. In summary, AFCIs are sophisticated devices that offer a high level of protection against electrical fires. By understanding how AFCIs work, their benefits, and how to properly install and maintain them, you can help protect your home and family from the dangers of arc faults. Remember to consult with a qualified electrician for any electrical work and to follow all applicable codes and regulations.